a little bit. So Carlos, I know him mostly through the COVID times, Zoom meetings. So I had a 2D sense of Carlos. I knew of him before that, but then after that, finally, we met some time ago, and now it's okay. 3D relationship. So
Love it.
Carlos is actually one of the philosophers of biology who is really pushing forward astrobiology. Like he co-edited the book in 2020 about it, has been publishing with philosophers, but also scientists on that in different venues, not just philosophical journals, but also science journals. So before going to the University of Nevada, Reno, where he's an associate professor there. He was with Ford Doolittle for a little while doing postdoc, hence the connection between Tyler, Carlos, and I.
And me.
Yeah. So it's thank you so much for making the trip. Thank you, Tyler, for actually putting this together too, helping to organize this visit. And let's have a great talk and great Q&A. Thank you.
Great. I'm still not used to ever being introduced. This is yeah. Anyway, yeah, thank you all for having me. This has been, I've been on a whirlwind tour, not just of the UK, but of Europe in general for the past couple of months, and I'm wrapping it up now. This was going to be the back end of it was going to bookend my tour, but there's still a couple of things that I added to the end of this. So yeah, I'm excited to talk to you about this paper that I've been very excited about for a while. I'm still trying to get it published. And if you want, you can. I should have checked this before. I believe if you go to carlosmariscal.com/Exeter, you can download the PowerPoint and follow along. And then if you click that link on the PowerPoint, you can download a draft of the paper if you want. You don't need to. So I'm Carlos Mariscal, philosopher of astrobiology. And I like to give, I always tell my students not to surprise me, so.
Don't worry about admitting people.
Don't. Somebody will admit them.
Yeah, be boring.
I always tell my students to tell me what you're going to tell me it, and then tell me that you told me that. So this is sort of what I'm going to. I want no surprises. I look at lots of people completely unsurprised. So. The end conclusion, hopefully this will make sense, and if it doesn't make sense, hopefully it'll make sense at the end of this talk. I want to say that what even counts as evidence is going to, in some sense, depend on how you interpret the word life, and I actually think that that this is going to be more general than this, right? So the talk is the nu n equals 1 problem. I'll tell you what that is. Shortly, but first, I want to say that we're going to end up here. So if this doesn't make sense quite yet, don't worry about it. I'll start with a little bit of a prologue. I sometimes like to think about how weird I can imagine life to be, right? We have a single example of life here on Earth that originated somewhere between 3.5 and 4.2 billion years ago. Everything that we see descends from that in some way, shape, or form. And so we have here life on Earth, and you can imagine thinking, well, okay, well, maybe if we found other creatures that look like us, but just had like different ears or something, then yeah, we would still count them as life. Yeah, that's not that typical. Life could be pretty weird in that way. You can imagine perhaps thinking, oh no, maybe biology can go in really different ways. We'll get some bug type creatures that are in the that are very, very big, and this is from the hit children's book Animorphs, which I used to read when I was yeah, so maybe biology could be really weird if evolution had taken a zig rather than a zag. Maybe we're talking about origins of life scenarios, and you're thinking, okay, there's these hydrothermal vents where maybe there's not quite cell-based boundaries, but there's still like diffusion across different gradients, and you can have like some distinctions. There's some stuff that could be happening, some heredity maybe, or some metabolism going on. Maybe you think that we don't need any chemistry. We just need like a certain kinds of behavior, right? So so maybe like a robot could be life. Fred Hoyle, a famous astronomer who coined the term Big Bang, wrote this fun little book called The Black Cloud, in which there's this black cloud that starts gobbling, is going to gobble up the sun, and it turns out that it's a sentient creature. And so the protagonists of the book make contact with the creature, and the creature is surprised that life could exist in squishy little bodies like ours. But everybody's like, oh, okay, so you convince the protagonists of the book that it was alive because it behaved in a certain way like life. So maybe the similarity you only needed the sort of behavior, you didn't need any of the complex structural aspects. Maybe you think everything's alive, maybe rocks are alive. I don't know. You can extend the concept to the breaking point, right? And perhaps you'll point out that you can't just have a single spectrum of dissimilarity. That's kind of weird, right? Things are similar and dissimilar in dozens of ways. You can imagine breaking things up into the form and substance. You can imagine 1,000 ways of dividing how weird life could possibly be. Okay. It doesn't, for my purposes, this doesn't matter. This is like a sort of an imagination exercise to see where your intuitions are. Because pay attention to those intuitions here. That's what I'm going to start poking at in this talk. And with that much prologue, let's get started at the top. Okay, it's this talk is divided into 4 sections: the old n=1 problem, the new n=1 problem, kinds of evidence, and evidence of kinds. There's a lot of like balance in this organization. I like balance; makes me happy. So I'll guide you hopefully toward this conclusion. We'll see. I started thinking about this n=1 problem. All life on Earth shares a common ancestor, or ancestry, maybe not a common ancestor. And so you might think of it as a single sample of life. And so if you are looking for life elsewhere in the universe, if you are looking to create life in a lab, if you're looking to find other origins of life that are still hiding in caves here on Earth, that kind of stuff. The n=1 problem is you're not justified in making any inferences about the nature of life based on that single sample size. You would never make big inferences on anything based on a single sample size. So given our single sample size, we're not justified in concluding whether features of life on Earth hold among other instances of the universe. So in other words, here's a self-portrait here of life on this planet. This is I think at this point, this is what, 8 years old. I really need to find a more updated version of this image. But this is things that we've sampled, some of the things that we've observed. Everything with a dot is something that we know exists, but we've never actually seen. So we can't culture 99% of all microbes or something in that continuum. And so the idea is you can't make any inferences from this to how weird life could possibly be. Roughly, it's structured something like this. A single entity has a lot of traits, a lot of features. Some of them might not generalize to the category. We might be led astray as to which features matter. Carol Clunan, who's written about this, I remember I was in an author meets critics session, critiquing her recent book. And one of the things she said was, biology needs to get over its Aristotelian hangover like all other sciences did. We need to figure out what truly is essential and what is accidental about life, which is an Aristotelian form of reasoning. but yeah, she also says something like we know life on Earth is non-representative. So here's a space-filling graph of various extremes, right? Temperature, pH, pressure, salinity, I think is on one of these. And we've detected creatures that you could put on any of these things, right? So that's a weird looking shape. I don't know what kind of shape I expected it to look like, but it's weird that life on Earth has expanded to find these niches in all of these little areas and not, made a nice, cool, clean shape that shows that we've explored all of life space. She says, we know it's non-representative. And so we're not justified in making inferences about life elsewhere. It has this really cool analogy. Assume that you're an alien biologist and you happen to abduct a creature from Earth, a single zebra. She didn't name it, so I decided to name it Zed. But you've abducted Zed, and you're asked to find the features that apply to all mammals based on this single creature. And so mammals are big, mammals are small, mammals are quick, mammals fly, mammals do all sorts of things. And you have this single sample size, this single creature. And she argues you wouldn't be able to make any inferences, any inferences of things that we actually care about based on this single creature, this single sample, right? So one of the things that we find quite distinctive about mammals is that they give live birth and they have mammary glands. And if Zed was male, you wouldn't have mammary glands. If Zed was alive or wasn't pregnant, we wouldn't be giving live birth. You wouldn't be able to make these inferences. So in earlier work, I pointed out some assumptions about this form of reasoning about the n=1 problem. So I argued that that it was assuming that there was only a single class to which your sample belonged that you cared about anyway. It assumed that if you were to be faced with other members of that category, that you would identify them as being of the same kind, right? So what we're looking for is these essential features, non-accidental features. Now, one thing that I pointed out in earlier work is there's all sorts of inferences you can make from Zed, right? You have a single creature, and you can make inferences about what the stripes are for, and what hooves do, and what its diet is like, and its symmetry, and all sorts, and that it's multicellular. You can make all sorts of inferences. They might not attach, strictly speaking, to mammalia, right? Mammals are this interesting, like clade that has a historically contingent past, and you might not be able to make generalizations from the single sample size to everything else, or at least to only that scale. But I still think that there's lots of things that you could say from a single sample size. And then I thought about it a lot more. And I've been thinking about this for the past couple of years. And so about a year ago, I started wrestling, maybe a little longer, started wrestling with this about how is it that I always find myself disagreeing with people again and again and again And we're all interested in life in the universe. I came to realize that there was something that was hidden, that was a mode of reasoning that was hiding behind how we were discussing these issues. And that's led me to formulate this new n=1 problem. And that is that life on Earth belongs to and provides equivalent evidence for an indefinite number of broader categories, none of which are non-controversially equivalent to the category life itself. So think about the Z example, right? Z can give you lots and lots of evidence for all sorts of interesting categories, all sorts of interesting classes to which this single zebra belongs. Maybe not strictly speaking, maybe they would not all apply to mammals, but they'd all apply to something, right? And so there's this hidden inference behind that analogy that I want to like maybe spell out here. Okay. So I've modeled this. I mean, it's called the mu n=1 problem because I want to model it off the new riddle of induction. Those of you that have studied philosophy of science know the new riddle of induction. You don't need me to spell it, but just in case, let's say you're making measurements, and at time 1 you see measurement 1-ish, and time 2 measurement 2-ish, all the way on till you get to a bunch of measurements. You get to about 13-ish, and it seems pretty linear, right? Your measurements are pretty linear. What is the next measurement? It could be that the next measurement is a continuation, like an increase. That seems to be the general trend that you see here. Okay. It could be that, well, all of them have been less than 14, right? So it could be that it continues, that it stops. It could be that it goes back to the average, right? There's literally an infinite number of things that the next measurement could be. And if you don't have an understanding of the causal structure of the world that you're in, you might not be able to distinguish which inference would be the most reasonable inference, right? Because if you're just making blind measurements, then yeah, sure, it looks linear, like a linear increase, but what if it's just linear to fill up a tank or something? Then it fills it and you're done. You shouldn't expect it to like expand beyond the limits. Okay, so anyway, an infinite number of inferences that are justifiable. It's about how if we are in a new setting, in a new environment, in a case with new data or new evidence, we're not justified in making any particular inference. You're sort of making a stab at the causal structure of reality when you make those inferences. So we have life on Earth, going back to the n=1 problem. Life on Earth. Some people look at life on Earth and the features of it that they find most exciting and interesting and intuitive are how it behaves, right? In the example of the black cloud, it seemed to behave, it could literally communicate with humans. So it was behaving in ways. Some people look at ChatGPT and think that it deserves some sort of rights or respect or something. Maybe not a current ChatGPT, some version of it, who knows? Some people look at life and they think that the thing that makes it most interesting and insightful is that it is, or most interesting and useful to study is that it involves like evolving entities. Some people look at it and think in terms of complex information or metabolite, think about it as a form of metabolism. What metabolism is independent of a theory of life, I'm not entirely sure about, but the point is that a lot of people look at life on Earth and they think, oh, the thing that makes it interesting, the kind of category that it is a part of is any one of these. There's an indefinite number of these answers. In my dissertation, I founded hundreds and hundreds of definitions of life. I wrote the Stanford Encyclopedia article for life, and I have these I have this meta table of categories of life. Just hundreds of people have taken a stab at being like, I have to find life, guys. This is my definition. And it leads me to have some deep skepticism that we're doing anything when we do that. Okay. So remember when Carol Cleland said, we know life on Earth is non-representative. We know it isn't. She said, look at this. This is weird. These are weird shapes. But every time I hear that, every time I think about it, I think it's non-representative of what? What is the thing that it is non-representative about? In her mind, and you know, in her writing as well, and in other people's writings, she's not alone in this. We're talking in terms of the range that chemistry can the range of possible chemical kinds and the possible environments, right? This planet doesn't have all of the pressures and temperatures that you can imagine in the universe, and so there's other sorts of chemistry. But anyway. Okay, so let's distinguish old problem and a new problem. The old problem, we don't know what properties are essential to life. The new problem, we know life on Earth has many properties, and you could actually think about them as essential to various categories, right? Some of these categories are fairly well developed and well understood. But which of any is the life category? And when you look at any of these attempts to define life, you'll see it's like it's almost like cooking recipes. Like, oh, life is of course an evolving system. It has a soupçon of metabolism, and you know, behaves in ways that it has information on top. A sprinkle of I don't know, certain behaviors. Okay, maybe that's not clear yet. Hopefully it'll be clear when we talk about the kinds of evidence that we could see. This is where the rubber hits the road. This is where the problem is going to show up. Let's say we're looking to detect life, right? And so it could be that it just crash lands on Earth and says, hey, take me to your leader. It could be that we find some muck in Enceladus or Titan, right? We're going to Titan in 2027 to see what's under those oceans. It could be that we just find some really interesting potential biosignatures or technosignatures in some exoplanets somewhere, right? Those are all of the ranges of things that I think are reasonable to expect in our lifetime. And I've broken them down into these sorts of this division. 1, very few people agree. 2, some experts agree. 3, everyone agrees. Hopefully I'm not forgetting anything. So very few people agree. We detect phosphine on Venus. We detect some methane on Mars. We detect WOW signal in the 1970s. We detect some things that when we sent the Viking landers to Mars in the 1970s, there was a bunch of experiments, one of which is called the labeled release experiment, that got some of the Martian regoliths, roughly dirt, and fed it a bunch of organics, and then saw if anything happened, and stuff happened. And then they got another one and they zapped it, and then they did the same thing and nothing happened. And so they were like, oh, therefore we detected life. Actually, just one dude said that, Gil Levin, the designer of the experiment. All of the other experiments did not find that. And so he went to his deathbed arguing that he had discovered life on Mars. And so this isn't, when I say, you know, very few people agree that we have detected life, there's multiple instances that you can point to where reasonable people like Chris McKay looking at the ALH 84001 meteorite argued that there was these fossils of life. Like multiple times respected scientists have said, hey, we've discovered life. And not everybody in the community has agreed with you. So, okay, they've often been simply dismissed. We can talk more about that in the Q&A about how to interpret that. I think the most interesting one is when you have cases where some experts agree, where we discover a thing that fits some, but not all of the conceptions of life. We go and we discover muck, and it's weird muck. It behaves in interesting ways, but it doesn't have any of the hallmarks that we care about. And you can imagine well-meaning scientists who just have a different understanding of what life is, asking this question, what is it like? Right? Actually, I think that's going to happen many more times before I die. So back to this comparison, there's a sense in which when somebody looks at evidence and they say, hey, look, I found this muck, it's life. And somebody says, that's not life. The person that finds it is begging the question against the alternative interpretation of what life is, right? It doesn't count as evidence if you have an evolutionary definition and you find something that's not evolving, somebody's like, oh, well, that shows that evolution's not a real thing. Other people would be like, well, no, that doesn't speak to what I'm saying. Okay. All right. Now, the ideal case would be everybody just agrees. Some alien just shows up. Everybody's like, oh my God, that's alive. Obviously, we're alive, that's alive. Everybody agrees. And that convinces everybody that whatever our definition of life is, whatever our theory of life is, it must at least include that new creature, right? I think the problem in this case is that it actually doesn't really give us new information to decide between competing views. If everybody agrees, you haven't actually tested any of the borderline cases. Okay, what are our options? Maybe we start finding a bunch of stuff out there. The JWST, the James Webb Space Telescope, has been out there for a year and change, and it's made some really interesting observations. Maybe we'll continue to make those observations. Maybe SETI will keep detecting things. Maybe it'll be so obvious we get access to the space Wikipedia and it tells us, oh, this is just what all of these things are. And so we all agree and we're all happy. Yay. We could also decide which of these, we could get into a room and then like hammer it out and figure out which are the features that we really, really, really care about when it comes to life. Remember, there's hundreds of definitions that I've quoted. So we could just convince each other, or we could kill everybody that disagrees with us. In my dark days, I sometimes wonder. Is that Max Planck that says science advances one funeral at a time? Yeah. Okay. All right. Let's focus on this first case, this hopeful ideal case. Is there already one? Oh yeah. Started at 3:30. Okay. So let's talk about sentiments of kinds. I don't think that this is actually that new of a problem. There's just an interesting way of representing what's going on here. I'm finding out that there's some sort of reference slippage going on in the concept of life, right? We have this term that we use in our daily language. Life makes sense when we're talking about the difference between a penguin and a rock. Penguin pushes a rock. Rock doesn't push a penguin. Life makes sense for a lot of our daily discussions, and then we try to bring it over to the scientific concept, and we still want to resuscitate that like folk concept. And we say, hey, our best scientific theories can capture 80% of our folk concept. That's good enough. And other people are like, that's not good enough. We cared, the last 20% was the thing we really cared about. Okay. Okay. So I actually think that happens a lot. I was just having a discussion about species with Tyler, and we were having discussions about other these biological categories. We'll talk about them in 2 slides. When I think about the kinds we expect to see in nature, the ideal that goes back 3,000 or 2,000 and change years is that there's these just natural divisions in reality out there. That every single intelligence, every single adequately placed intelligence could distinguish between maybe not tables and chairs, but between like life and non-life, and between maybe elements in the periodic table. Right? Those are and maybe we don't want to use the same essential accidental distinction that Aristotle might have pushed, but there's still some ways of carving that are better than others. Other people say, well, maybe there's just these property clusters of things that you can identify as having a real non-accidental affinity with each other. I don't know why I choose, like, some huge percentage of people are red-green colorblind. I don't know why I put red objects here, I'm sorry. These are all red objects. Sorry. But yeah, you know, you can just look at perhaps some wavelength and say, even if you could not perceive color, that still captures some real division in nature. There's still a set of properties that we really care about. To be contrasted with something that's more of a conventional kind, right? If aliens landed here on Earth and they say, hey, tell me what a game is. Why are all of the games in this part of the story, not in that part of the story? Why do we have them all? Like, there's not a really good way of explaining it to them without explaining deep culture to them, right? Like, without explaining human culture to them. And then the last bit, you know, maybe they're just arbitrary groupings like chips and shoes and ceiling wicks and cabbages and kings, which are only grouped there because they were grouped by Lewis Carroll in the book once. You know, there's not a lot that makes them belong together. And I think that when we look out into the world, we see a lot of things, and it just seems like I see the red of Adrian's hair, and I think, it seems like it's a property of the object itself. It doesn't seem like I'm adding to it. It doesn't seem like it's a convention of it. And it feels like that. I feel like the world that divides into red objects and non-red objects. I feel like gold is different than silver, right? We at least have a better theory there. So maybe one of my favorite podcasts, No Such Thing as a Fish. It's based on a quote by Stephen Jay Gould that says, the more I study fish, the less I think the more I think there's no such thing as a fish. You have this folk fish concept. Lives in water, swims, has fins, has scales, and has gills, goes along with chips, right? And so we feel like reality, the world is divided in such a way that these things, there's a reason we group them a certain way and not other ways. But then biology comes around and says, hey, actually, you know, there's historical connections here. And in fact, when you look at things that we call fish, the word fish in our language, like about 95% of those would be things we call ray-finned fish. And so maybe you want to say, that's just what we mean by fish, right? Other people are like, well, actually, we want to include sharks. Sharks are fishy. They have fins, you know, it's pretty good, it's pretty fishy. And so when we look at this, we see that there's a problem, right? Tetrapods, us and other things like us, branch within the lobe-finned fish. And so, so in a fairly untrolly way, you could actually put dolphins in there. There's this quote, right? The relationship between a lamprey and a shark is now closer than that between a salamander and a camel. Actually, I haven't gone into how many millions of years separate them, but sharks are older than trees, so, you know, I believe it. Okay, so we have this folk concept of fish. I have a lot of folk concepts that it turns out when we apply our best science to them, we have all of these choices. Save 80% of the phenomenon, save all of the phenomenon in really arbitrary ways, save only 20% and argue that it's the best, that kind of thing. And so what we end up doing is we try to come up with these property clusters that explain the phenomenon in ways that capture all of the things that we care about when it comes to the phenomenon in question. Going back to the case of life, we see that the difference between a pigeon and a rock, I think I said penguin and a rock last time. The difference between a pigeon and a rock, they're still also very different, is huge. And so because it's so huge, we think, oh, we'll come up with all the property clusters that separate them, and we can come up with a nice cohesive definition. And then we run into all of these problem cases where all of the property clusters that you want, you have the best definition you could possibly devise won't really make sense of the RNA world, or if it does, it might not make sense of viruses, or it might not make sense of synthetic biology, it might not understand prions, it might not understand life, it might not give you operational criteria for looking for life on other planets, right? We have so many of these marginal cases, so many of these borderline cases that you can either choose to cover them all and have a very arbitrary set of conditions that won't help you predict what anything else would count, or you can come up with a theoretically unified definition of life or theory of life that carves out some of them but not others. But then when you try to discuss with somebody that's carved out different clusters of these, you're begging the question against each other. Okay, so we have all of these these problem cases. We've seen that there's no agreement, but I don't think the future shows that there's going to be any more agreement than what we've already seen. So I think all that's left is either to decide or kill everybody. Life, what is life is a decision, it is not a discovery. All right, let me wrap this up. It's been speaking for a little while. There are an indefinite number of answers over what category life is. Any evidence can speak to an indefinite number of categories, and it won't just speak against other categories. What is life is a decision, not a discovery. Thank you.